Good morning, Elise. Nathan, say good morning to Mike. What? Mike, he sits right next to you. Poor guy's just sitting there hoping someone would talk to him. There you go. I ask him how his day's going so far. I ask him what he's doing. Now I ask him for $20. Good morning, Hannah.
Morning.
Morning, Abby. Morning, Alyssa. How you doing, Sanuja? How you doing, Lilia? Someone's calling my name.
I didn't hear you, sir.
Oh, that's all right. Morning, Reese. Hi, Drew. Hi, Josh. Ooh. If you need a calculator, you might as well grab one right away. Alyssa, did you say good morning to Hannah yet? There you go. Morning, Haley. Good morning, Allison. How you doing, Isaac? Good morning, Kaylee. Good morning, Addie. Oh, that's the bell. That means we should start. So, although because of this pandemic year, I haven't started this way very often, but in a normal year, I always kind of like to start with science in the news. And if anybody's heard anything about going on in the world of science, is I can, it's good to know what we use science for. Now, I don't know if you listened to the news yesterday, but the International Science Foundation, they came out with new recommendations for research on embryos. And one of them was to advocate for the creation of animal human embryos. So I don't know how much you remember from biology, but what they wanted to do is genetically take stem cells from animals and combine them with stem cells from humans, and then to grow those such that you could have a animal that would grow human organs. So we kind of already do that right now, where we'll surgically open a pig and insert a human bladder and grow a human bladder inside a pig, and then sacrifice the pig and then extract the bladder for people who have bladder cancer. We do that with heart valves, kind of the same thing, but actually pre-programming it from the start, we haven't done. And again, the idea would be that you grow a pig, but the pig would have then human embryo or human stem cells in it, so that the pig would have, let's say, a human liver, so that you can remove the liver and then use that for a liver transplant instead of having to always do organ donors. So I just thought that was interesting. And the other thing is, if you're looking for different careers in science, we need bioethicists, we need lawyers. So even if you're not the researcher, Soren, you could be somebody who, let's say, works on the bioethics of it, if that's the sort of stuff that interests you, or maybe helping write the laws. Because here's another interesting, this was done, I believe, at Princeton 2 years ago. So, when does death occur? You know what the definition of death is? Is it when the heart stops beating? It's brain activity. They look for certain brain waves. When the brain stops functioning, that's when death is considered. So what researchers at Princeton did is they took pigs that were being butchered for ribs and spare ribs and all that stuff. They took the heads, so they butchered the pigs. Then they gave the heads to the researchers, and the researchers circulated oxygenated synthetic blood through the pig's head. And they were able to monitor conscious brain waves for up to 2 to 5 minutes after the head had been severed from the pig. So they administered anesthesia and painkillers to the synthetic blood so that the pigs would not be conscious, and that they wouldn't feel any pain, but they were alive, at least according to the brain activity. They were alive for a good 10, 15 minutes after their head had been severed from their body. So so that's kind of so why I bring that up is the pigs were considered dead because their heads were removed from their bodies. So then there are no really set of laws for experimenting on dead animals. You can pretty much do anything you want to a dead animal. But for a live animal, there's a huge set of regulations and rules of what you can and cannot do, from rats all the way up to chimpanzees. So for these pig heads, are those considered live, or are those considered dead? So if you're looking for an interesting career, Haley, you could be a bioethicist and advise researchers on, because they didn't have to get approval for this because they were experimenting on dead animals. If they were experimenting on live animals, they would have had to get prior approval. So just thought that was an interesting area of science. By the way, so I kind of gave a pro for making human animal embryos. because you can harvest organs and treat a range of diseases. The big downside of it is you are possibly creating what we say a vector or a transmission route from viruses from animals to humans. So how do viruses jump from one species to another? Mutations, right? But if there's a mutation in a, let's say, cougar, okay, I'm not going to catch a virus from a cougar. Why? Because no one keeps cougars in their homes. But chickens, goats, pigs, these are all animals that people keep in their homes. Now you're saying, what do you mean, Mr. Strauss? People don't keep these animals in their homes. Not in the first world, but in the third world. When I taught in India, at nighttime, you'd bring your goats, your chickens, and your pigs inside your little dwelling because you don't want them running off and you don't want someone stealing them. So that's why a lot of those diseases start in third world countries, because there's very close contact with humans and animals. But if you're growing human organs, Nathan, in animals, would be an easier way then for viruses to jump species. So just a interesting aside there. Any other questions, comments? Anybody else have science in the news? You got something for us, Anuja?
How long did you teach in India?
Just a summer. I was doing some missionary work. We were teaching some of the women in the poorest areas how to run daycares. So, because there aren't in some places of India, there is not very much options for women. Like either you stay home or you're basically property of the husband. So we were trying to teach them how to run little daycares in their neighborhood so they could have a little bit of an income. It was great. I loved it. I'd go back. India's got amazing food. Once you come back to the United States from India, you realize all of our food has got ketchup and mayonnaise on it. It's disgusting. All right, sorry. All right, let's get to science. Why don't you take out your labs? We'll finish that off today. Yeah, take control. I also taught a summer in Poland. Taught English. Then I was in Guatemala. Okay, so we got one graph done. Actually, I better make sure everybody at home can hear me. Can you give me a thumbs up at home if you can hear me? All right, it's always good to check. All right, so we got our first graph done, and I want to point out on here, so what happens to the volume of our gas as temperature goes down? Decreases, right? So you see this line, if you continue to drop the temperature, volume gets smaller and smaller and smaller until eventually our volume is 0. Can you have a negative volume? No. So we would say that's the absolute coldest you can get. So there's a limit to how cold you can get, Elise. There's no limit to how hot you can get, okay? You can have 1,000,000 degrees, you can have 1,000,000,000 degrees, you can have 1,000,000,000,000 degrees, but there is a limit to how cold something can be, okay? All right, so today we are going to graph we got through number 5, right? Okay, so we are going to create a second graph today. And the second graph is going to be based on the dry gas. So our T1 and our V1 stay the same, but our T2 is now going to be paired with V2 dry gas. So if you need to refresh your memory, on our data table, here is our T1, here's our T2, here's our V1, but instead of the V2 wet gas, we're going to use V2 dry gas, okay? So again, I don't care if you use notability or not notability. I don't care if you use graphical analysis or Desmos, but let's go ahead and create our graphs. Make a new one. So you'll have to go into manual entry again. Do all the labeling. You use your own data. By the way, V2 dry gas should be smaller than V2 wet gas. Should be smaller. Celsius. And once again, get your graph to go out to negative about 400. And then get your curve fit on there. There we go. I'm going to walk around the room and just help people while I've got mine here. If you need help, raise your hand. And bring it up. Click on that feature. Linear regression. And then, you want to be able to see where it crosses the y-axis. X-axis. So you want to be able to see where it crosses the x-axis.
What? I want.
We have economic research. Use, so both of those will be now. Who's your lab partner? Okay, just write down his. For some reason, sometimes it doesn't work, and you have to go back. You have to I'm not sure why it's doing that. So just write down the equation. All right, so are you guys at home good? Get the graphs done? So we're gonna need to write down, if your dry gas is bigger, you're probably put into your calculator incorrectly. Some people still, so there's really nothing I can do because I can't show you, Abby, how to do it over Zoom, because I don't know what calculator you have, but my guess is, Abby, is that you're not using your calculator correctly. So all I can say is go back and keep trying it again until you get the correct answer. But you're going to need it to eventually get the correct equation. Yeah, I know, Abby, you're using your calculator wrong, but there's really nothing I can do to show you over the Zoom how to use it right. All right. So let me write down my equation. Y equals 0.6516. You could, Abby, Google like the type of your calculator and then go online and Google how to use it. Or I'm sure it came with an instruction manual. You can probably read that too. That would show you how to use it right. Or if you have time during resource, I could show you how to use it correctly. So so what you're gonna have to do, Abby, is you'll have to come back and recorrect it and then just redo the answers later, okay? All right, so there's my equation for the wet gas. What does the x-intercept represent? So what does this point represent? The temperature at which the volume is 0. Another way you could say is the coldest you could possibly get. Oops. So I'm just going to recopy my equations right here. So here are my two equations. So this, Abby, once you figure out, or we can set up a separate Zoom, once I show you how to use your calculator correctly, then you'll have to come back and redo this part, okay? So we're going to solve for that coldest temperature. So what was on my y-axis? Volume. What was on the x-axis? Temperature. So just a reminder, whatever on the y-axis goes where y is, and whatever on the x-axis goes where x is. So instead of y equals 0.5898, it's v equals 0.5898. So let's plug in 0 for both. And solve for t. And of course, you're going to use your own data. Okay, EJ, you're using your own data. With 3 sig figs. I should put units on here, sorry. Bad, Mr. Strauss. So I'm just going to walk around and check to see how people are doing on this one. Should be negative, right? Oh, yeah, you still got to solve it. Okay, calculators on. So put a 0 in for y and solve for x. If you need a calculator, there's some in there. We can do F4 classes right now. What hour do you have resource? That's 5th hour.
Yeah.
So you could come in 5th hour today and we could have a do lab. So we're just calculating these things right now. You gotta bring the 237 over to that side and divide by that. Well, that's pretty good. Not so good. It's all right.
So
Try that one then.
Algebra correct.
Yep. You just bring that to the other side and then divide by it. Yep. So let's bring the 185 to the other side. Divide by 0.950. So you go subtract, bring the 185 to the other side. Divided by 0.950. So it'd be negative 194. Because I was lazy. So you get subtract 185. Subtract 185. So you get 185 is equal to 0.95x. So then you get negative 185 divided by 0.950. And then you do the same thing on the other side. So then you got to bring that to the other side.
If I divide by 0, I get error. If I put 0,
Why are you dividing by 0?
because we have to move these over here to keep x by itself.
Okay, like honestly, all of you have theoretically taken algebra, but I'm kind of amazed. All right, so here, let's learn. So if y is 0, what's my next step algebraically? Subtract 218 from both sides. So that cancels. And then I have this. Then what do? Divide by that. And that's what gets me the negative 370. So that's the proper algebra. So there's no 0 there. You're subtracting that, bringing that to that side, and then divide by that. About a couple more minutes to finish off your math here. And then we're going to Abby, what type of calculator do you have? What's your brand? Scientific calculator. Okay. My guess is what you're doing here is, I don't know for sure, but my guess is when you're doing this calculation, multiply, 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 then you divide it by that, and then you divide it by that. Okay. So mathematically speaking, if you have A times B times C divided by D divided by E. A times B times C, you're dividing by D. If D didn't exist, you'd be dividing by E. My guess is you put this into your calculator, A times B times C divided by D times E. That tells me this, A times B times C divided by E times E. That's not what you want. This should be divided by E. Because A times B times C divided by D divided by E, that's the correct way to enter it into your calculator. That's my guess. I don't know for sure unless I can see you do it. All right. Let's move on. So what is the actual value of absolute zero? The theoretical value is negative 273.15. That's the absolute coldest you can get. You cannot get colder than that, Mike. You cannot get to negative 274. It's impossible. So negative 273.15 degrees Celsius is the coldest temperature possible. There is no upper limit to heat, but there is a lower limit. The formula for percent error is E minus T divided by T times 100%. So you're going to take what you got in your experiment, subtract the theoretical, divide by your theoretical, take the absolute value times 100%. So you're going to do that for both of them. All those negative signs makes it a little tricky. So go ahead and calculate your percent error. And while they're doing that, Abby, maybe you want to go back and try recalculating this thing, but make sure you're dividing by both of those. Just times 100. Times 100. The theoretical is negative 2. For everyone, don't.
For the second one, I got more. You just have different data. Like we got. Oh, no, I mean, that's the one I got first.
Yeah, here's. Yep. Scroll this up a little.
did everything I could. I just got.
Percentages are gonna vary. Yep.
18.
I saw that. You can just argue with that. Oh, because you did minus 270. Yeah. Yeah. 9.8.
It's just you probably did. Yeah. Just doing memorization. Did you do the practice with the?
All right, number 10. Based on your graph, is it possible to make the gas so cold that the volume of the gas is 0? So looking at your graphs, is it possible to get the volume down to 0? In theory. In theory, can you get the volume to 0? Yes, right? Based on the graph, if you keep making it colder, your volume is going to continue to drop. So in theory, yes, you can get your gas volume to 0. So in theory, if we kept getting that gas colder and colder and colder and colder and colder and colder and colder, the volume of the gas would disappear and go to 0. So now my question is, does that make sense? I'm just going to draw a piston. Here are my gas particles. If I lower the temperature, what's going to happen to my volume? Just to answer that, what happens to your volume if the temperature goes down? Goes down, right? Can I compress my gas all the way to 0? Could you take a gas and compress it all the way to 0? This is where we're trying to stretch your brains. If you cool that balloon and the balloon starts shrinking and shrinking and shrinking and shrinking, can you get it all the way down so that the volume of your gas disappears? No, because a gas, even though it's not very dense, is something. This is not possible. Because what will happen when you get really, really small? You'll get to a point where you cannot compress the gas anymore. Because even though the gas is not big, you'll get to a point where you can't compress it anymore. What really happens, Charlie, is if we took all the air in the classroom, we started squeezing it. We kept squeezing the air and squeezing the air and squeezing the air. Eventually, the gas would condense into a liquid. And if you kept squeezing it and squeezing it, the liquid would then turn into a solid. Okay. I don't know if you remember that Boyle's Law Lab where we had that cylinder and that crank. And we had our pressure gauge over here. What happened eventually? We couldn't go anymore, right? The pressure just got too high. If we would, in theory, keep cranking on that and getting the volume smaller and smaller and smaller, eventually you'd see liquid condense on the inside of that cylinder. Okay. And if you really kept cranking on it, Hillary, that liquid would condense into a solid or freeze into a solid. So even though our graph says it can happen, in reality, no, it does not make sense. You can't turn something into nothing. It's like saying I'm going to squeeze Drew and compress him, and then eventually he's just going to disappear. Can't happen. All right, number 11. So again, this is a good problem for the ACT. Here's our equation, right? There's our equation. So that is in the equation of a line. So what is K representing? Slope. So your constant is your slope, right? So all we left off here was the y-intercept. So your K is your slope. So this is how they determine the constants. Your constant is just your slope. All right, number 12 and number 13, well, it's just the summary. So number 12, you guys should be able to know enough to answer number 12. And then write your summary. Remember, in your summary, you're going to state your results. So what did you find? What type of errors could have occurred? And then number 3 should be how to fix errors. Okay, so first thing you do is what did you find? Number 2, state your errors. And the third thing is how to fix your errors. Now, I'm not trying to be mean here when I say do not write about if you like the lab or not. I'm just trying to remind you, as you go on in science, when you're in college, Reese, when you write a lab summary, do not put in there, this is a really fun lab. I really liked it. I'd love to do it again. Your professor is going to look at that as being very immature. So don't ever put in your summary whether you liked it or not. They don't care if you did. So, so take this time. I'll give you, you should be able to write your summary in like 5-10 minutes. And then when you are done with your lab, please upload it and then work on the Fruit Loop worksheet. So for the remainder of the time, you know, let's see. I think I'll just collect, like if you're a virtual student, please upload it. If you're in person, I'll just grade your worksheet. Okay. So yes, you need to do number 12. So finish the lab. And then 2, finish Fruit Loop. So you have 2 things for homework: to finish the lab and finish the Fruit Loop worksheet, but you've got a half hour to do both of those. So everybody at home, you've got the remaining half hour to finish your lab, upload it, and then work on the Fruit Loop worksheet, okay? I think tomorrow we'll try having groups present. We'll see how that goes on the Fruit Loop lab.
Temperature of the wet gas was higher than the dry gas by using the formula. P1, V1, divided by P1. Yeah, it says P.
You guys at home, it should, number 12 should say step 8. Step 8, not step 4. So if you don't equalize the pressures in step 8.
I'm doing the summary.
Because I answered the question. When it's asking us for the summary, what kind of like results are they looking for?
So what did we find in the lab?
Like the stuff we calculated?
Data. So don't share data. Share what did you find?
Can you see the calculator now?
Yeah, I can.
Okay. So I did it like a few different ways and I came out with like the same answer every time. So this is the way I originally did it, was like
Can you
this.
slide it over a little bit so I can see there you go.
So that was the first way I did it.
Okay, just wait a second. I'm gonna try here and see what I get. So I got 300.
That's what I got too, but that's bigger than my original number. That's why I didn't.
Let's see here. Wait a minute, that's 302.4. That's 302.4. Your pressures should be different.
Oh, yeah. Okay. I was putting in the wrong pressure on one.
That'll
Okay.
do it.
Yep,
Okay.
thank you. Could you also do on the Fruit Loop worksheet, could you
Yeah,
do
that one,
the
yeah, I can do that one for everybody. Okay.
HCN?
Anybody need any help? So again, not only do I want you to get the lab done, I want you to get a good start on that Fruit Loop lab, okay? We've got still 25 minutes.
I think it is, yeah. That's all I'm.
Another thing that would be important to cite this by how much. So don't just give me the words. Don't just say we found out that a temperature decrease and volume decreases. How much does it? We found an equation, right? And then we also found like how, I mean, you just proved there's a lower limit of temperature. That's kind of important. to figure out. So why did we wait?
It's like.
Right, because if the water level is set and outside,
I need to show you something. It's so
then we
bad.
know the pressure inside is atmospheric pressure. Yep. So that's why we bring it to the pressure.
It was too big on me.
It's
It just fit horribly.
just a slope.
Ugly and terrible.
It's
Look
the
how it
slope.
fits
All you gotta do is make the slope.
And Ellie.
Got your slope right there. Slope, slope.
It's so bad. And there was nothing I could do about it. That's so funny. It was so bad. I cried when I say it.
When you're done, you can pile up your.
Take your rain on it.
Bring in your silver bottles.
False, number 12. Make sure to put the you like the lab. No. I said that because it explicitly says, do not write about how you like the lab. No one cares if you like it or not.
I said I didn't really love it because there's no physical boom.
Yeah.
All right, number 12. I don't know how to be effective. It's that. Is it? Yeah. How it's effective, not why.
You probably will.
You guys done?
No. Oh.
I'm trying to figure out because I had to write this on my computer. computer for the first four, so I'm trying to figure out what I did for number 4 and my test.
Number 4. I mean, if it's easier to upload it, you can upload it.
Yeah,
Would that be easier?
well, because I only have the
So
first
you could take a
4,
picture, because you could take a picture of this
and
and
then,
upload all.
yeah,
together.
I'll probably
that's
just
fine.
use it.
We can say this is step 8.
Yeah, step eight.
Okay.
Yeah, it's step 8 for 12.
All right. Both graphs using that. So that's when we found the temperature, right?
And then probably the other important thing is what else we can prove that it's lower limit to how cold something is. That's kind of big. So we raised the work with that, right? So water level of certain amounts of- Why? Why did you?
Can we just say another?
No, not ever. Another thing that we found. Here's my eraser. So that's the one where we plug in zero. So what we're- so that's- so is- That's that.
But what did we even use those numbers for after? Just
Right here, by the percent here.
Yeah, I think it just affected percent error. I'll see what else had changed.
The low temperature volume of gas.
That's the only thing I can think of that it would change. Because you don't use the number in anything else. I think I'm just gonna write that.
So I said, also that lowest temperature of the volume of gas. Yep, negative. Oh. Possible.
Yes, and yes. I can do a copy.
There's more to capture.
That error would be affected because numbers, number 8.
Water quantity.
Yeah. Slow. Is, this is an equation of a line. Right? Slope is half. You're not doing an equation. All you're doing is literally writing the slope. Why am I doing that? Because I'm trying to get you guys to understand. When you take an ACT and they ask you questions like volume is proportional with temperature. What's the value of the constant? Then you can say, oh, I don't have to do anything. I just have to look at the slope and I know the value of the constant. Because this is the form of life. That's what I'm trying to teach you. And this works for physics, it works for anything. So like I'm trying to find velocity times velocity times time. The slope is your acceleration.
Oh, this makes sense.
True, but that's the
Yeah, I was
mathematical
trying to
test.
read it, I was like, I
So-
don't know.
the reason why were we lowering and raising the flash to the volume inside and outside? of the sink? Oh, not the volume, the water levels inside and outside. of the sink. Well, you found the temperature difference with the thermometer. Why? Why did the water level inside and outside have to be the same? What was important about that?
For it to be like not as submerged as the other one.
So what causes the barometer? What causes the liquid to go up?
Is that it?
Air pressure pushing down. So if the water level,
Oh, it's okay.
so if the water level inside and outside is the
Say
same,
that.
the pressure inside and the pressure outside must be the same. If the water level is higher, it must be the air pressure is greater and pushing it up in.
Oh, okay. I'm just gonna keep what I have and then just add.
Yeah.
So can I keep what I have and then add that part?
What questions do you guys at home have?
It's 6 innings or something. Remember when that guy ran on the other side?
Yeah.
We were going bye. Oh, yeah. And then one of the guys did it and it was funny. You're supposed to have a game today, but I don't think it's gonna happen. And we were chirping that every time, the whole entire time. We were talking about. The only two we played really chirped hard all year for Memorial. Because they were like talking trash to us when we were warming up. I don't know. And stuff, and then, but like 13.
So. If the boundary.
Kenny, that was one of the I did like the worksheet yesterday night. I thought it was this morning. Does it do it tomorrow before class?
Yeah.
Oh, this is on campus, it says it's still a student.
I changed it.
Oh.
I swear I changed it.
Oh, mine, no, mine's. Two at 8 this morning. Or late. No, it's like due May 27th, available
What?
until May 28th. Okay.
How do you not know?
Oh, so I do that. That one is the same color. And how do you really? I think you made the choice, but I don't know for sure. That's how I have mine. Yeah, I don't know. That's why I did that one. That's really. That's what I did.
There's a stack of lamps over there. One second. You do H and C. Find the difference between H and C, find it down to anarchical down, and you start all over and see C and anarchical down.
How do I do? No, this
Okay, so it's carbon, it's carbon and 4 chlorines.
oh, I thought it was I.
No.
Oh.
So the carbon is in the center,
Big one. Yeah.
and then the 4 chlorines go around.
I thought it was an I.
Well, I do this. Will it ever be where, like, it's a 3-thing compound and then it's like one is ionic?
My grade.
Yeah, for you guys, no. The one that's classic example, this is my oxide. That's an ionic bond. And then basically what happens is, so I just did that flawless. Steel, sorting bond. Then this thing. The bond, I don't know. Sodium hydroxide.
It's kind of flat.
But I don't put those on here. I do.
No, my problem is instead of doing it this way,
So it's actually that, but be kind of late to, like, I might show it to you guys, but I don't test it out enough. Test on that. Plus, we're not having another hair. Yep.
For the 3 ones, you just like put them on.
I do.
I did a dot plus. Okay. With the C2H6.
Yes.
And then.
So I just want to remind you guys at home to upload your lab when you're done. That's due tomorrow. And then the Fruit Loop worksheet, you want to help each other. Now, copying from each other is not helping. Explaining it to each other is. And tomorrow, we're going to try having groups present. We'll see how that goes. But I'm going to break the groups, this class up into groups of 2. They're going to put their answers on the whiteboard and then they're going to present them. Okay? If you get stuck on any of them, you can always email me or.
I have a question. What do we do if it's 3?
So
How do we decide? Yeah.
So you do it between the hydrogen and the carbon.
So subtract.
So that would be 0.3, right?
Yeah.
But then you do it again between those 2.
Okay.
So that would be also covalent.
Okay.
Right? You get the same answer for these 2 as those 2. So everything's covalent.
Mr. Strauss,
Yep, I'm here.
is there a way for you to like email me my annotated like test?
Didn't I do
So I
that,
could-
Abby? Because you took it online. Didn't you check your email?
Oh, maybe you sent one. I didn't see one, but I can check.
Double check. And if I didn't, just email me and say, hey, could you email me the test? Because when someone takes it online, I grade it in Notability and then I just share that Notability file with them.
Okay, if there's a possibility to do a retake, do you take the retake score or the best
You
score?
take the retake score. It's not the
Okay.
highest of the 2.
Okay,
Can you have a test on this? Okay. Are you taking?
Yeah.
I don't see an email from you with the
Okay.
notability test.
Then email me and I'll send you the Notability file sometime this afternoon.
Okay, thank you.
I got a little excited on the call. I was so. I got a cute. No, this one, like, Lord, no one down here. Oh, yeah.
See you later, Ruby.